All right. Chapter number 9, Introduction to Networking. And as I said, everything is branching out of networking. So you need to have a good understanding of networking, and then we can go back to IoT. What is network? Joining more than one computer to each other is the computer network. Joining devices so that one device can talk to another device, you made a network. When you join your phone with the Wi-Fi, you created a network. But that is as easy as that you just join. The one who set up that network is the guy who has done the job. You are just a part of it. You just become the part of it by becoming a client. But who does that basic networking? Network engineer will does that basic networking. So a network consists of two or more computers that are linked together to share the information, such as a computer that is connected to a printer, and they are able, so if I want to send a print to a network printer sitting in the other office, not at my desk, some other part of the office, and I can go and take my print up from there, that is network. Even if I connect my local printer with my personal computer and I try to print, it is printing, it has become a part of my computer, and I am talking to each other as a part of network. But if I'm able to exchange files with the help of that, so the devices are able to okay, so once they are able to talk to each other, they will be able to exchange the file between them or allow electronic communication, so they are able to see each other. Remember that ping command, when I said, okay, this is my computer's IP address and that is my computer's that is my network IP address, my router's IP address. So if I want to see if that router is still alive, I send a request, are you still alive, please reply back, and it says yes, I'm still alive, I'm sending you the reply back. So that is electronic communication happening. The computer on a network may be linked through cables, Wi-Fi, telephone lines, radio waves, satellites, infrared, and fiber optics, right? So all these are the parts of computer network. And look at this, they have given a reference, just like when I asked you guys that put a reference. They are not just copying and pasting this definition from some random place, but they are referencing these slides. What is internet? Internet means interconnected networks, a network of networks in which user at one computer can, if they have permission, get information from another computer, and some talk directly to users at other computers. So this is internet is basically networks of network. It's just a network of network. It's a whole big network. So if you have information residing on the Google, you go onto the Google and get your information from that part of the network. Google server has its own IP address. What is device network? A set of devices connected through the link. A node can be a computer, printer, or any other computer capable of sending and receiving the data. The link connecting the nodes are known as communication channel. So we will have a communication channel, but communication channel does not mean that you have unlimited access to that channel. So the internet coming to your home, you have a bandwidth associated to your what you pay. So let's say Shaw 75 for which you pay. You get some bandwidth for it. Let's say 75, a random number. Shaw 300, that's a different package. You pay for it, you get a little bit more bandwidth, faster internet connection. So the more you pay, the more bandwidth you receive from your internet service provider. So it's like a pipe. Under that pipe, the data is flowing, just like water stream is flowing. The amount of line that you acquire from that pipe in that bigger pipe, if you acquire a smaller line, you will have smaller internet connectivity, slower internet connectivity, because the more time it will take to squeeze in data to get to your house. But if you pay more and you have a bigger hole, the more data can flow through. That is why you pay more for that package which they deliver to you. So what is the network device? That is why it is called communication channel. Linking the nodes, linking the computer. When you talk about nodes, devices, computers, they are all the same. This is a general name of node. We are all nodes here. I'm connected with the internet, and this computer is a node, one endpoint. This is the endpoint communication. This is where my internet is coming and ending at my system. So node can be a computer, a printer, or any other device capable of sending or receiving the data. Usually, network printer, we send the data to it, so it prints out the data for us. We shared the file with it, so it is at the receiving end. When we scan from that printer and send an email to us, we are actually sending the data back to the computer. So computer networks uses distributed processing in which task is divided among several computers. Instead, a single computer handles the entire task. Each separate computer handles a subset of tasks. So if I bought a $30,000 server and I try to install every possible software on it to say that this computer will handle this main server will handle this, and this, and then I have a list of 100 items that one server can do, my server will choke. But why it will choke? Because it has limited memory, limited capacity. It is not an Azure server that I purchased. I purchased a server with a limited capability. So the way we can handle it is making virtual machines on that bigger server. Creating virtual machines to say this virtual machine will have this task. This virtual machine will have this task. And remember, virtual machines are created on the host. Virtual machines are the guest operating system. They are not the host operating system. So on the computer network, there is not only one service running. There are multiple services running. And if you choke all those services on one physical computer, then your physical computer might not be able to handle all those services. That is why you make service breakdown, or you might have two servers of a cheaper. So you break down and disintegrate your server services. some of the devices that you see on the network, on the computer network, is the hub. This is a USB hub, but this is the network hub. It is from D-Link, as you are seeing. This is from network. This is a hub. Hub, what it does, it's a dummy terminal of the internet, which takes the computer, which takes the internet, and you plug it into one of the port, and the rest of the port will be distributing it just like your outlet at home. So hub will broadcast the request to the entire network. All the devices will check whether the request belongs to them or not. If not, the request will be dropped. So that's a problem. Hub broadcasts to every computer, and if computer says that, oh, this request does not belong to me, then that broadcast is useless. Only the computer who is concerned in that request will acknowledge that. Other than that, everybody else will disregard, which is different from switch. Switch will give it to only to that computer which it belongs to. So if you look at this line, a switch does not broadcast the message to the entire network like the hub does. So hub is really dummy, because hub is broadcasting to everyone, and just only one or two acceptors will be accepting that request. Switch will only give to the message to whom the message is purposeful for to be transmitted. So a switch is a hardware device that connects multiple devices on a computer network. A switch may contain more advanced features than hub. Switches have their own operating system. What is the most popular company for computer network switch making? Cisco is the most popular company. The other company is called Juniper Networks. Cisco Networks, Juniper Networks, they are the two most popular ones. There are some other companies might be as well, but these are the two popular ones. A switch contains the updated table that decides that the data is transmitted or not. So switches are smart devices as well. So if you are on the network where the switch is, switch knows your computer. For the first time, it might not know if there's a new computer added, but once your computer is in its memory, it is actually being cached into its memory. They are almost like the computer of their own. They have the memory of their own. So it will store your information in its memory. So next time when you transmit the data through the switch knows, oh, I already know this computer because I've sent the data to this IP address in the past. It's in my table it's in my repository of my database, and table means database, right? Not relational, but at least a database. I know this computer and I can transmit this data to that computer now faster than detecting it and then sending the data. First time it may take time to detect all the routes. Second time, once it has acquired the knowledge of it has become smart, then it will start to send the data at a faster pace. Therefore, we can say that the switch provides direct connection between the source and destination as it increases the speed of the network. Switches are made for that. They maintain the cable to send out the information. And switch is also smart enough, knowing that if one computer or the part of the network has gone down, it automatically reroutes itself through another gateway, through another route. So it will say, let's say, for example, don't think right now too much about it, but let's say if you are going to your office each and every day through one route, and one day that route is shut down for construction or repair. What do? You reroute yourself to go to the college again. So you take another route and you go to the college or your office. Switches does the same. If it knows that this is the best possible route, it will choose that route for you automatically. And if that route is currently shut down or that part of the network is currently down, it will reroute for that temporarily and it will go through another route. We all know about router, what we know, what it does. So I will leave it for you to read. So they are going through each and every devices right now. So you can go over these devices when I will say no more to the class. But here I want to go on the last few topics of this for today to just go over. I'm just going over. Yeah, I will go over some other topics tomorrow. I think I will stop at client server networking. So the slide I was showing to you in the PowerPoint here is actually available in chapter number 9, this slide. So you don't have to worry about that me giving this picture to you. This is the client server model. It is coming to you in your slides in a moment. Different types of cable. This is a whole chapter for it. I'll just go over a little bit here, but there's a whole topic for it with the different types of cable. So if I need, or if I see if there is a need for it, I will share the slides with you, connectors and everything. As you see the feature of networking, there is no one beating Azure and AWS on that. At your local company, you will not have this much resources that you can increase the security. You cannot increase the scalability. You can increase the scalability to a certain level. The reliability of the local network might not be as good as what they are providing on the cloud, but there is some reliability and scalability and security still prevail. But imagine getting the security from Microsoft versus implementing your own security. Which one would be better? Microsoft security. Device network architecture. That's where I want to come to. There are two types of architectures. One is peer-to-peer, and the other one is client-server architecture, which I discussed with you. So what is peer-to-peer network? What is peer-to-peer networking? Peer-to-peer network is if you join one computer with another computer, not the computer connected to a server, but if you join a laptop, my computer that is sitting here, that if I able to join this computer with my another computer, that is peer-to-peer network. There's a problem with the peer-to-peer network. With the peer-to-peer network, if I have created a user on this computer on which I'm taking the lecture, and then I have a laptop here, my computer, the user that I created on this computer and the user that I create on my other laptop will not know each other because they are not connected through a central computer which says that I have the database of all the computers and the users. Peer-to-peer means just device-to-device communication is happening regardless of the credential, regardless of username and password. These computers know each other. Yes, it is pinging, and that computer is also pinging. They're saying, okay, are you still alive? The other computer says, yes, I'm still alive. That's about it. But you cannot do too much networking with that. After 8 or 9 computers, this peer-to-peer networking starts to fail. So you definitely need peer-to-peer. You definitely need client-server network model so that your users can get authenticated. So peer-to-peer means computer-to-computer communication. So in peer-to-peer computers, if there are 5 or 6 computers that are connected, if one computer has the file, the other computer has to get the file from that computer which has the file. But if you put it on the server, then you have the file on the central computer. In the client server architecture, if you have put the file in the central computer, everybody can access that file. But in peer-to-peer computer, that does not happen. If that particular computer has a file, I need to fetch it from that particular computer. I can go by the IP address and get that file from that computer, but I need to know which computer has that file. So the peer-to-peer meaning computers are connected in a random order. So this computer is connected with all the other computer like this. Then this computer is directly connected with this computer. And also this computer is also connected with this computer as well. So there's a direct communication and there's an indirect communication as well. But there is no rhyme and reason in this networking. This computer can connect to this computer at any by just throwing a cable. So imagine there's a bunch of cable throughout the floor spread out, and you are connecting this computer with this computer. How you will connect this computer? You will connect through the ports. The ports at the back of the Ethernet ports at the back of the computer. You will plug in the Ethernet cable on one computer, and you plug in the Ethernet cable to another computer, and there go the communication has established. But how long and how far that kind of networking will go if you have 5 disconnected computers and if you have wires all over the floor? This will not going to last too much. Usually this can last up to 10 computers most. After that, peer-to-peer networking starts to fail. The linked computers are linked with an equal privilege and responsibilities of processing the data. So there is no security of the file sharing. This is the advantages and disadvantage of peer-to-peer. I have just gone over a little bit on this. So you can go over that. Network architecture, central computer to which all the devices are connected. Printer, all these laptops, desktops are connected. But only problem is single point of failure. It is also called as star network. As you see, it looks like a star. And the good point is, if one of this laptop goes down, network will still continue to work. If you go up, if the data is stored on this computer, and if this computer goes down, this computer here cannot communicate with this computer, because the only way for it to connect with this computer, it has to go through this computer and then establish this connection, unless we have this kind of communication. Not ideal. Advantages and disadvantages you can read again. I did create, in the previous course, I did create a client server architecture for you. I was almost there. I was able to make my virtual machine connect to my virtual server, and I was able to give the username and password was popping up. I was able to bring that, and I was later looking on why I was not able to get into that network, and it says it could be some security issues or ports blocked, which is good that it was checking that there is some kind of a security or the block that I have to remove so that I will be able to connect to the server. So server is not a joke machine. It is a serious business machine. That is why there are some security rules are in place. Server is managing all the resources such as file, directory, and the printer. That is why this printer is not an ordinary printer. It is called as network printer. Everybody is getting benefited. They will send the data to the server. Server will then send the data to the printer. Same thing. This guy will send the data to server, and then server will send the data to the printer. If this guy wants to communicate with this guy, he will have to go to the server, and server will send the data packet to this other guy. So there is some kind of a protocol or rules that are being followed in the client server architecture. The client server architecture contains a centralized system. Therefore, we can back up the entire data easily. So if we have the backup of this computer daily, and if this computer goes down, we can bring in another server and replace this if we have the backup of it. Not as easy as it's been said, but at least we have somewhere we can restore it back to. This is the expensive architecture, where the server requires larger memory. Azure made it a little cheaper for us by paying it on a monthly basis. It requires a dedicated network administrator. You definitely need your network administrator to maintain this structure, and you definitely need a network administrator to maintain it over on the cloud or on Azure or AWS as well. I'll stop here and I will go over types of network tomorrow, but my main focus was to give you introduction of what is networking, what is the main part of the networking, what are those devices, get used to those devices. This is part 2 of our lectures, but we are covering it as a part 1 first. So I want you to read up until at least these slides, up until this first 16 slides, and whatever I have gone over before showing the slides, you need to have knowledge of that. Any questions? All right, Annie. So you have the slides available for chapter 9. Please go over that, and I will say goodbye to you guys. If you guys are done reading, you are welcome to leave. But for the starters of this lecture, please stay and read these slides, and then you are feel free to leave after that once you are done reading it.